Hello everyone, welcome to our Sky Tonight program. This is Seth again, curator of astronomy for the Lohman Planetarium. And in this episode, we're covering the dates of January 11th through January 17th. And we're going to mainly talk about two things in this episode. We're going to kind of call this the Orion episode. We're going to really discuss in quite a bit of detail the constellation Orion. This is one of the best constellations you can see at this time of the year, and one of the best for all year. And so I want to talk more about the stars and objects within it. And we're going to talk about where the moon will be as we go through the week. So let's get to it. Even though Orion the Hunter starts to rise earlier in the year, even late last year at the beginning of the winter time, this time of the year here in January, I think, is the very best time to appreciate the constellation we know as Orion the Hunter. So if you're looking towards the east, right after the sun sets, so we'll speed up time here to watch the sun set. Actually, it will be behind us, but we'll watch stars and objects rise and become visible in the eastern part of the sky here as we speed up time. What's nice about this time of the year is Orion is pretty high above the horizon right when it gets dark. You don't have to wait around too long. You don't have to search too much to find this great constellation and the bright stars within it. And so what we'll do is we'll stop the time at a really convenient hour. So we'll probably go to about 7 o'clock. By then, a lot of people are still up and awake, and hopefully we'll have a chance to see this wonderful wintertime constellation. Just to go over the basics of this constellation for those who are not as familiar with him, what you want to find first, and what you'll probably notice first, are the three stars of Orion's belt. Many people are familiar with that star pattern, and it's very noticeable. So the three stars of his belt are not the brightest, but they line up in a pattern that are easily seen. So if we look here in the east, again, this is still 7 o'clock, we'll find these three stars in a row, and they're pretty lined up. And so it does sort of look like the waist or a belt of a person. Once you find that section of Orion, you can find the rest of him pretty easily. So to the north of those stars, or for our view to the left here, you'll see some bright stars that form the shoulders of Orion. That means his head would be about here. We go back to the belt here and then go to the right or to the south, you'll find these two bright stars. One star will be much, much brighter. These are the legs, the feet, or even sometimes the knees of Orion. So you could just say this is the bottom half of Orion, the middle section here, and the top section, the torso. And if you really look a little more carefully, there's even some dimmer stars that form maybe Orion's club above his head. Sometimes artwork depicts him holding a club. In front of him, you'll see a curved group of stars. Sometimes you see him holding a shield or a bow, like a bow and arrow. Depends on the artist who draws the picture. So just to put this all together, we can outline Orion, and he really does look like a person in the sky. So this particular constellation sort of looks like what it's supposed to be. There are so many other star patterns that are very hard to imagine and to figure out. Orion is not as bad. It really does look like the form of someone kind of stuck into the sky here. And this is just the outline, and there are different ways to outline him, but this is kind of the general look. And so what I always again notice is the body of Orion looks like a bow tie, in my opinion. Like this is the middle of the bow tie, and the legs and then the torso kind of look like the ends of the bow tie, with a bright star here and a bright star there, kind of on either side, opposite ends there. And let's just put up the artwork that is used in Stellarium, and this art can change depending on the artist and who came up with the drawing here. And so here he is, and in this picture he's actually holding an animal pelt or a skin. That's another option I didn't mention that he may be holding in front of him. So it just depends on your imagination or the imagination of the artist. So what makes this group of stars so well known all around the world is not only because these stars are really bright and prominent, and of course in other cultures this wasn't Orion, this would have been other characters and other objects. It just depends on the culture and civilization. But these groups of stars were recognized by people all around the world because they're very well placed in the sky. they're in a very convenient spot. To help us understand that, we're going to turn on something called the celestial equator. And the celestial equator is basically Earth's equator that is basically projected up to the sky. And we can zoom out of here to see what I'm talking about. And that divides the sky, just like it divides the Earth, into a northern region and a southern region. So stars up here, these are all northern stars, and stars below it, these are all southern stars. So look at where Orion is located on the celestial equator. It's right on it. And so that means that no matter almost anywhere you are on Earth, Orion is somewhat visible to you because it lies on the equator, kind of the middle section of the sky, if you want to call it that. And so it just depends on where you are on Earth, what the orientation of Orion will look like. Here in Florida, where our museum is located, we're pretty far south. We are north of the equator, but still far enough south where Orion is very sideways, at least when he's rising up from the east here, as you see in our location. But let's say you go more north, and we can change our location here on Stellarium, and just kind of click on the map pretty high up here. We'll go maybe parts of Canada or somewhere else, and look at the difference here. This is still near the same time, maybe a little bit before, but you'll notice here that Orion is more upright as he rises up in the east. Okay, so you can see the difference there. Let's change our location again, and let's go kind of more near the equator here. That's just slightly north of the equator. And you can see again, he's pretty sideways, almost exactly sideways, rising at the east because he sits on that celestial equator. And we'll go to the southern hemisphere. Okay, so we'll just move farther south here in South America. We'll go even farther south than that, just to really illustrate what's going on here. And the time might be a little off here, so let's speed up time just a little bit. And now look in the southern hemisphere. He's still there, but he's upside down, right? And so you notice how he's sort of turned and rotated around depending how far north and south you are from the equator. But as you can see, still visible as I move around the Earth, even extreme, maybe even going to Antarctica. Now, of course, this time of year, it's near the summertime there, so they have daylight all the time. But part of Orion is visible, not the entire constellation, but you can see part of him there, just above the horizon. So even that far south, still visible. Let's say we go really far north, really extreme north, getting near the North Pole. Now we're winter time for the northern hemisphere, which means it's very dark for most of the time of the day in the northern, extreme northern latitudes. And there's Orion again. Not very much of him visible, but it's still possible to see at least some of him. So you notice almost any latitude on Earth, you can find the stars of Orion, making him a very well-known area to almost everyone. Now coming back to Daytona, where we are about 29 degrees north latitude, starting out in the evening, Orion is mostly sideways, but one thing I will mention, he does turn upright for us if you do stay up later, and as you allow him to get to the south here, you'll find that then at that point for us here, he'll be right side up. So it does depend on the time and where you're looking at him from. But it's kind of interesting to know how he looks depending on your latitude. Of course, an important aspect of Orion is the mythology surrounding him. And as I mentioned earlier, there are many cultures around the world that celebrated the stars that make up this group we now call Orion. Of course, the Egyptians had beliefs about those stars. People in South America, people in Asia and China, people all over the world had their own understanding of these stars. But of course, here in the US and many places kind of go back to ancient Greek and Roman mythology. And that's many of the stories that we hear of Orion today. And they have changed and have been adapted quite a bit over time, like many of the other stories of all the other constellations in our sky. They can change and evolve depending on who's telling the story. And in a couple versions of the story of Orion, Orion is this mighty person. He's large, very powerful, almost a giant in a way, very handsome, and was the most prolific and one of the best hunters anyone had ever seen. And in one story, the goddess named Artemis, who is the goddess of the hunt, she was the one who pulled the moon across the sky, and her brothers named Apollo, who pulled the sun across the sky. Artemis saw Orion hunting and kind of fell in love with this skilled hunter. And she fell so in love that she left her goddess duties of pulling the moon, came down to Earth, and they fell in love. And she basically gave up her moon pulling duties. Apollo did not like this. And in one version of the story, he tricked his sister by making Orion look like an apple. And he dared Artemis with a challenge to see if she could shoot an apple from far away using her bow and arrow skills. He was basically testing her, but she didn't know that Apollo had changed Orion's appearance to look like an apple. She pulled back her arrow, shot the apple perfectly as she normally would, and she was horrified to know she killed Orion by mistake because Apollo was not happy with his sister not performing her goddess duties of pulling the moon, and she placed Orion in the sky, shooting an arrow into the stars to make the constellation. In another story, there was a version of Mother Earth named Gaia who noticed that Orion was killing all of her animals. He was such a great hunter. He was killing off the most exotic and beautiful animals on Earth, and Gaia did not like this, so she sent a giant scorpion, now known as Scorpius, to attack and kill Orion, and the scorpion succeeded. In many stories, they actually killed each other, and the god Zeus decided to remember this great person by putting him into the stars, that you could see him every winter time, at least in the northern hemisphere. And those stories can be different depending on who told them, but many of these stories kind of weave together to form the lore, the mythology of Orion. It's kind of fun to go back to them and figure out why people celebrate Orion and how they thought of him. And in some of those stories, Orion was not alone. He was accompanied by 2 hunting dogs, and they're quite easy to find, actually. Orion's belt here actually points downwards towards this star, which is the brightest in our sky, known as Sirius, which is part of Canis Major, the great dog. And just above Canis Major's head, a little bit north of that dog, you'll find 2 stars here that make up the small dog, known as Procyon, or Canis Minor. And this one takes quite a bit of imagination. I always joke and wonder how people imagined a dog from just 2 stars, but that's just how these things go. And so the 2 stars make up the small dog, Canis Minor, and that star there is called Procyon. So in many of those stories, Orion was not alone. He was with his 2 hunting dogs that helped him on his adventures. So as you look at Orion the hunter in the sky, what's great is to really marvel at the bright stars and objects within him. So let's just zoom into him a little bit more. We'll turn off his picture as well to get a better view of the stars within him. And as we look at him a little closer here, I always take note of those really bright stars on either end of him, on his torso and on his legs, divided by the belt stars. So we'll start with one of my favorite stars of all, this one right here, this reddish looking star that marks the right shoulder of Orion, because normally he is portrayed as looking at us from the sky. So this would be his right shoulder. And that star has the fabulous name of Betelgeuse. Just a great name, easy to remember, and it marks a very bright star that we see here. And this star is quite interesting. Even the name has an interesting story, and what we like to say Betelgeuse today is probably nowhere near what was said a long time ago. It's actually part of an Arabic word, and there are 2 terms that are brought up. One is Ibt al-Jauzah, which means armpit of the Great One or armpit of Orion. The other one is Yed or Yad al-Jauzah, which means the hand of Orion. Some folks speculate or debate if the first one, the armpit of Orion, is really true and if that was just a misinterpretation of the meaning of the name, but that's still debated upon, and so you see those 2 versions. And so we think that at least one of the versions, maybe the Yad al-Jauzah, the Y was confused with a B, and eventually kind of became Beit al-Jauzah, and then maybe Beit al-Juz, and then eventually Beit al-Giz was a word, or Beit al-Gis was a way to say it. And sometimes you see some folks even say Beit al-Juice or Beit al-Gis, until today it just became Beetlejuice. And that was the easy way to say it. And so these things change over time, pronunciations change, and interesting kind of where the history comes from. So originally Arabic, that has been transformed into the word Betelgeuse that we use today. Now astronomically, Betelgeuse has always been known as what's called a red giant star. So a star at the end of its life and is not burning hydrogen in its core anymore. It's now burning helium and bloating up. And we've known for quite some time that the star is way bigger than our sun. It is cooler than our sun because red stars are cooler. It's a wavelength of light with lesser energy. And as a star expands, it cools, but does get brighter as well. So we've always known this is one of the largest stars you can see in the sky and one at the end of its life. And it is a bit of a variable star, so it can get a little brighter and a little dimmer over about a 420-day period. That's been known for quite some time. And it still normally is the 10th brightest star in the sky, so it is ranked among the brightest that we see anywhere in the sky at night. But what was really fascinating was in late 2019, this star dimmed dramatically. It was very surprising, and astronomers had never really seen the star dim this much. Normally it's the 10th brightest star. It became a very average looking star. It dimmed so much, and I remember seeing it too around that time, late 2019, early 2020, and it looks so different and very odd to see this star just kind of blend in with other stars in the sky. And it was a very mysterious event that astronomers were racking their brain over, trying to figure out why the star was dimming. There are all sorts of ideas that maybe it was about to explode in a supernova, maybe some type of dust cloud went in front of it, maybe even some type of weird ship went in front of it. That one was pretty far-fetched, and really no one took that one seriously. But there was all these interesting ideas about why the star had dimmed. And in December of 2019, astronomers took this image from the VERS instrument on the Very Large Telescope in the Chilean desert. And it's always been known that there's this dust around the star, and this is an infrared light. And zooming in on this star, we get another image of the actual star itself from what's called the Sphere instrument on the Very Large Telescope that shows kind of a little bit of a darkening. And that darkening is what caused the dimming of the star. And so what was convenient was the Hubble Space Telescope in orbit above the Earth was aimed at the star around that time and was taking images of the star in ultraviolet light, which reveals the layers above the surface that you can't see with visible wavelengths of light. And what was found, and this image kind of illustrates it, this is an artist's sort of rendition of what happened, a big bubble of material kind of, I like to say, burped from the star, and the star is a pulsating, very dynamic star, and you have these convection cells that rise and fall. And sometimes you get a huge amount of material that sort of burped above the star, in front of it in this case, and that material, which was really, really hot, 20,000 degrees, moved millions of miles away from the star and then cooled down. And that's what you can see kind of in the panels here, that material kind of moving in front of the star, it cooling down and turning to dust. And that big blob of dust blocked light from the star and dimmed it considerably as it kind of sat there before it moved away. And so that was thanks to Hubble that helped us understand this process, because this was seen over time. And so these kinds of interesting things going on help us to understand how stars are dying and how they live out their lives and what happens to them at various stages. And what was also revealed in 2020 was that Betelgeuse is actually a bit smaller and a bit closer to us than we realized, because it actually dimmed again later in the year, not as much as it did in late 2019 and early 2020. And that was kind of due to its normal 420-day cycle, the second dimming, and it confirmed that the star is in its helium phase, burning helium or fusing helium. And so normally we thought the star was bigger than the orbit of Jupiter, which is massive. But the star has been brought down a little bit, down to maybe the orbit of Jupiter. If you could put Betelgeuse where our sun is in our solar system, it would expand maybe out to Jupiter, maybe a little less. So even though it's considered to be a little smaller, it's still massive in comparison to our sun and our solar system. And a little bit closer. Normally we thought that Betelgeuse was 600, 700 even light years away. It turns out it's probably about 530 light years away. So the light from the star takes about 530 years to travel from it to get to us or so. And so it's a bit closer, and since it's a little smaller and at the stage that it is now, we think that the star won't explode as soon as we originally thought. We thought maybe it would explode in about 10,000 years or so, or maybe even now, but now it looks like it probably will go supernova in 100,000 years when it runs out of more of its fuel in its core. And even though it's closer to us, it doesn't mean it's going to hurt us if it explodes at some point. It's still very far away. But what's interesting is, now that we know a more accurate distance measurement, when that blob of material left the star, that actually happened about 530 years ago, and we're just seeing it now. That just gives you an idea of how far these things are. So Betelgeuse is a very interesting star going through changes at the end of its life, a little smaller, a little closer to us than we originally realized, but interesting nonetheless. And now it's pretty much as bright as it normally is at the right shoulder of Orion as this large red supergiant star. Now the other notable star in Orion, which is actually brighter than Betelgeuse and a different color, is his left foot. And that's the star we find here, which we call Rijl. And Rijl is a blue supergiant star. It may have Arabic origin as well, where the original name was derived from the term Rijl Jauzah al Yusrā, or the left leg or foot of Jauzah or of Orion. Sometimes it was referred to as the left leg of the Great One or the left leg of the Central One. Again, translations change over time, but the first part of that name, Rijl, is what we still use today as Orion's left foot star. And it certainly is a bright star. It's ranked about 7th in our night sky of brightest stars, and a very hot star as well. So when red stars are cooler, if you move along the spectrum of light, you get to blue, which has more energy. Blue stars are the hottest type of star in the universe. And so this is a type of star that the temperature on the surface is double the temperature that you'd find on the surface of our own sun. And it's so very luminous, even being about 860, maybe 870 light years away. And it's about 79 times bigger than our sun. And even though Rijl is not bigger than Betelgeuse, it's still huge. So this is a cool video that explains the size relative to our sun. And our sun is already really big. You see at the left of the video here. And this is comparing to some other stars. Sirius, the brightest star in our sky, is a blue star. And then we get to some red giant stars that are much bigger than our sun. So you saw the sun on the left there, how small it looks compared to these red giants, Pollux, and then this next one is Arcturus, which is one of the brightest stars in our sky. But then we're going to get to the blue star Rijl, and it is way big for a blue star. It is huge. And that just gives you a sense of it there. If you look at the left of the screen, there is the sun. And then here is Rijl. And you can see it is a massive blue type of star. Again, much hotter, much more luminous, and brighter than our sun, marking that left foot of Orion. As far as deep sky objects go, Orion has some of the best. And one of them is quite famous. It's underneath Orion's belt. So we'll zoom in a little bit more from this view here. So there's the belt of Orion. If you look underneath it, it's supposed to be the sword of Orion. At the tip of the sword, with your naked eyes, you might see a little bit of blurriness. Maybe a star with some blurriness there. But if you have a telescope and you could zoom into this area, so let's kind of center this and zoom into it. And what you find is a big cloud of gas in space called a nebula. And this particular nebula is the Orion Nebula, one of the most famous star-forming regions in our sky. It's about 1,300 or so light years away. The light takes about 1,300 years to travel from this to get to us, and it's where stars are being born. So to see the Orion Nebula in any detail, you definitely need a telescope, but even a small telescope will reveal some beautiful bluish gas around the new stars that are very, very bright. In other wavelengths of light, you see different colors and different things brought out, but in visible wavelengths through a regular telescope, you'll see this bluish gas around it. And it's one of the coolest things I point my telescope to at this time of the year. Now, as we zoom out of the Orion Nebula, we can find another deep sky object relatively nearby, actually just above it, near one of the belt stars of Orion. This star right here is called Alnitak. And just underneath it, if you have a pretty big telescope, you could possibly capture or see kind of the silhouette of an interesting shape. And this is what we call a dark nebula. As we zoom into it, you may have seen this before. It's one of the best pictures also that the Hubble Space Telescope imaged some years ago. And this is called the Horsehead Nebula. It is so beautiful. To me, it actually looks like a seahorse more than just like a regular horse. But either way, some type of horse-like creature or something with the name horse in it. And it looks really cool. So this is basically a very dense cloud that's blocking light from getting through it. And so it's creating a silhouette. So that's where the dark nebula comes from, because there are some clouds behind it that are very bright, that are what we call emission nebula. So they're emitting light, and this is blocking some of it, creating this really interesting silhouette. And you can see some other nebulae nearby as well as the Flame Nebula right there. And so it's just a gorgeous area for astrophotographers right near Alnitak, one of those belt stars of Orion. So it's really, really nice to find that. Now, taking in the overall scene of Orion and what we've talked about, if you have the right equipment, you'll notice some other objects kind of surrounding the constellation. You see very faintly here in Stellarium. So this picture here of the same area of the sky taken by an astronomer who, using special equipment and also what's called a hydrogen alpha filter, allows us to see hydrogen at certain wavelengths of light that you couldn't see with your eyes. It reveals how interesting and beautiful the Orion constellation is. And so just to provide context for what you're seeing, here is Orion's belt, the 3 stars in a row right there. There is Betelgeuse right there. There's Rijl, the left foot right there, and some of the other objects we mentioned. Here is the Orion Nebula, the beautiful star-forming region. And if you look carefully, right here is the Horsehead Nebula underneath Alnitak, one of the belt stars. So if we look a little more closely at everything around this, there's so much more. So if you look next to Rijl, see this kind of bluish gas here? That's another nebula called the Witch's Head Nebula, because if you turn it upside down, it looks like a witch's head. So you got like a nose right here. There's like the long chin. I think that would be the eyes right in this area there. And the blue light from Rijl is actually lighting up that nebula, creating the color that you see there. If you look kind of wrapping around the belt and through much of the constellation, this huge loop of gas, of hydrogen gas. This is called Barnard's Loop. It's part of the overall what's called the Orion Molecular Cloud Complex that we see here. So it's a huge loop of material that you see here. And then near the head of Orion is the Lambda Orionis ring that we find here. And some speculate that maybe a supernova explosion happened in the middle there and created much of the material you'll see here. And there is some star-forming activity going on in this area. So if you have the right equipment and the right photography skills, you can really bring out all the beautiful deep sky details you can find in Orion, which really shows you it's such a beautiful and interesting place. So as you can see, Orion the Hunter is an amazing constellation with so much to look at. And as I mentioned earlier, this is such a great time to enjoy the constellation as it's up right after the sun sets. You can see it for most of the night, and it really shines beautifully at this time of the year. So hopefully you can enjoy Orion. And now that we've spent so much time talking about Orion the Hunter, the last thing I just want to mention is where the moon will be after sunset. There's some nice evenings to watch the moon rise above the setting sun. So this is a little bit later in the week on the 14th, which is Thursday. And if you're looking really close to the southwestern horizon, you may find the very thin crescent moon rise right up in here. And not far from it is the planet Mercury. That is getting higher and higher and a little bit farther away from the sun. That's actually Jupiter here, but it is now descending so close to the sun you're not going to be able to see it. And if we watch the moon for the rest of the week here, as we get into the weekend, you'll see the moon rise even higher up as we get into the 16th. And then the 17th will be even more of a waxing crescent moon as we see a little more of it in this area of the sky. So that'll be kind of nice to kind of end the week with a really beautiful crescent-shaped moon moving away from the setting sun if you're looking more towards the west-southwestern part of the sky. Hey, that's it for this edition of our Sky Tonight. I hope you enjoyed it, and thanks again for tuning in. So if you're in the area in Daytona Beach, please stop by the Lohman Planetarium. We are running shows safely and every single day, so we'd love to have you stop on by and check us out. But of course, you can always find us here online digitally each week talking about the highlights of that week's night sky. So hope to see you back here again. Thanks a lot, take care, and happy stargazing.